Now that we've seen many different methods on how to factor, what if I was given a problem and we have to use all these applications, all these tools in order to do a factorization of a polynomial? So what I have for today is to look at a general strategy on how to factor these polynomials. And I have a few-step process here in order to factor a polynomial. First off, the very first thing, as I've said in previous videos with this, is you should always look for the GCF, the greatest common factor of a polynomial. Factor out that GCF and be sure to include it in the final answer. Also, if the leading term is negative, then factor out that negative as well. And then the second step is, after you factor out GCF, if one exists other than 1, look for the number of the terms. If there are 2 terms, look and see if it's a difference of squares, a sum of cubes, or a difference of cubes, and if so, you can use those tools in order to factor those things. Also, a little note, the sum of squares are prime. They cannot be factorable, cannot be factored any further. And then secondly, we added trinomials here. Again, trinomials if there's 3 terms. If the trinomial is a perfect square trinomial, then factor it out. Make it a quick and easy step for us. If not, you can either factor it using the x squared plus bx plus c method we used, or when the leading coefficient is not 1, you can use the AC method to work with it as well. Also, if there's 4 or more terms, then you can try to factor it by grouping. Let's see, for your third step, always factor completely. And then last but not least, check your answer, making sure it works. So let's look at a few examples here for today and see how we can factor these all together. So for numbers 1 and numbers 2. Number 1, we look at this, and first and foremost, as we always do, we take a look and see what the GCF of these 3 terms are. Since this is a 1x squared and not all of them contain an x, the GCF here is 1, so we don't have anything to factor out. And then secondly, I see this is a trinomial. I can do maybe what 2 numbers multiply up to 10, 100 I mean, and add up to negative 10. But I also see what the square root of 100 is 10. Square root of 1 is 1. 1 times 10 is 10. Twice of 10 is 20. So this is a perfect square trinomial here. So therefore we'll have 1x squared minus, because the middle term is minus, 10 squared, and that's how we can factor it. Another way you could have done it, you could have said, look, 100, that's negative 10 times negative 10. So that's x minus 10 times x minus 10, or that's x minus 10 quantity squared. For our second one here, first off again, I look at all the terms. There's 4 terms in this case. The GCF again is just 1 here. And so I'll go to step 2. And step 2, what I have for this, it's a 4-term polynomial. So I'll use a factor by grouping with this. So go 2y cubed plus 10y squared plus the y plus 5. So I'll look and see what are the GCF of the first 2 terms. I can factor out a 2y squared, and we'll get y plus 5. On the second one, it's already y plus 5. The GCF is 1 out there. They both have a term of y plus 5, so I can factor out this y plus 5. And what is left over is this 2y squared plus 1. Now, I didn't check on the previous one. That was step 2. Step 3 is to see if you did this completely. Y plus 5 is a linear factor. This is as far as you can go with this one. This is a squared factor, but since this is a plus in between, remember you cannot factor a sum of squares if this was a sum of squares anyway. And so this is factored all the way. One other thing you do is you can check this as well to make sure what we have up above is what this obtains to be. And that is correct. So therefore this is our answer. For number 3. First off, is there a GCF in here? And I see a GCF, but also remember the highest term here is negative. And so I'll factor out a negative. They both have a factor of 10. And they both have 2t, so I'll factor out a t squared from this as well. So negative 10t squared goes into negative 10t to the fifth, t to the third time. And negative divided by negative is a positive, so it would be plus 8. 10 goes into 88 times, and t squared will come out as such. Now, is this factored all the way? T cubed plus 8. Oh, wait, 8 is t2 cubed, isn't it? So therefore, we'll have a sum of cubes here. So we can use the sum of cubes tool in order to factor this further. So first off, I brought down this negative 10t squared. I'll drop off the cube, so it's going to be t plus 2. Square the first term, that's t squared. Multiply the 2. And square the last term. 2 times 2 is 4. I will do the opposite sign, always positive. And so this is our answer for number 3. So when I look at number 4, we have 6x squared y to the 4th, 21x cubed y to the 5th, and 3x squared y to the 6th. So when I try to factor this out, I see they all share a common factor of 3. They all share a factor of x squared. And they all share a factor of y to the 4th. So let's see, 6 divided by 3 is 2. X squared comes out, so does y to the 4th. Then we'll have minus 3 goes into 21 7 times. There's still 1x left over. And there's a y left over. Then we have plus, the 3 comes out, the x squared comes out, and y to the 6 becomes y squared. So for this trinomial, can we factor this any further? Well, we have a y squared, we have an xy. This is kind of weird. We should have an x squared in here if we were able to factor this any further. This is not factorable any further. So do you say this is prime, this is not factorable? And actually it is factorable because we just already factored out the GCF, so therefore this will be our final answer. Okay, so this we can't factor out any further, this trinomial, but we already did factor out the GCF, so this would be the factored form of this original polynomial of what we've had. So how about numbers 5 and 6? So for number 5, as we have 3 terms here. And for the GCF, let's see, 98, 280, 200, they all have a common factor of 2, because 98 is 2 times 49, and 49 is 7 times 7, and 7 does not go into 200 at all. And they all share a common factor of x. So when I pull out a 2, we get 49 x squared plus 140 x plus 100, and I factor out the 2x out of each of these. Now, let's see, can I factor this trinomial any further? Let me try one thing. Remember the perfect square trinomial? The square root of 49 is 7, so we have 7x here. And the square root of 100 is 10. 10 times 7 is 100, doing it in my head. It's 70x, but when you double it, that's 140x. So this is a perfect square trinomial for us. You can also use the AC method, but this becomes large numbers and it can become very difficult. So when you do use this quick method, you say, look, this is 7x plus 10 squared is what this would be. And don't forget to bring this 2x down. And that's our answer for number 5. Whereas for number 6, let's take a look at this one. Now the leading term, we have a negative, it's an m squared, so I'm going to pull out a negative first and foremost. So I have 10m squared, change the sign, so this is plus mn, change the sign, so this is minus 3n squared. Now we could have rewritten this where the 3n squared is in the front and the negative 10m squared is in the back. You can do that also. It's a very similar answer to this. So when I look at this 10m squared plus the mn minus the 3n squared, is there a GCF amongst those? And the answer is no, there's not. I'm going to use the the AC method to this. Grab that 10 and the negative 3, which is negative 30. And I look for two numbers that will multiply up this negative 30 and add up to a positive 1. So we know 6 times negative 5 multiply up to negative 30, and 6 plus a negative 5 is a positive 1. So this is factorable, and these are our two terms we can work with this. I'm going to use the AC method I used in an earlier video. I'll go m plus 6 n, because there's an n squared, and then m minus 5n. So I'm using these two terms of the coefficients of the n's in both these cases. But remember, this is not my answer because we have this coefficient of 10 in front. And with that method, you divide both these terms by that coefficient, which is at 10. Try to reduce this as far as possible. Let's see, 2 goes into 6 3 times, 2 goes into 10 5 times, 5 goes into 5 once, goes into 10 twice. So those are the reduced fractions. So my final answer is, first I'll bring the negative down. I'll take that 5, put it as the coefficient of the m, and this 3 will be the coefficient for the n. This 2 will be the coefficient of the m, minus the 1 is the coefficient of the n. Now since it's a 1, we don't need that, and so let's go ahead and erase that and just make this an n right there. I want to check my work on this one to make sure I'm right. And so see, 5m and 2m is 10m squared. 5m and negative, that's negative 5mn. We'll have a positive 6mn and a negative 3n squared. This negative will change all the signs. So I'm going to change this in negative, positive, negative, positive. And so overall I have a negative 10m squared, let's see, positive 5mn minus 6, that would be 1, minus 1mn plus 3n squared. And is that what we started off with? The answer is yes, it is. So I know this is my final answer for this problem. Number 7. What if you have x squared y squared plus 7xy plus 12? Now it's a little tricky because we haven't seen x, y squared, but this is the same thing as like xy squared plus 7xy plus 12. Like in the past, we have like x squared plus 7x plus 12. So our xy is like our variable. So since the coefficient is 1 here, all we need to do is look at the 12. Are there two numbers I'll multiply up to 12 and add up to 7? I see 1 and 12 won't work. 2 and 6 won't work. Oh, but 3 times 4 does. So therefore we'll have xy plus 3 times xy plus 4. And that's our final answer there. And lastly, for number 8, we have x to the 4th minus 16y to the 4th. And so first I'll find what is the GCF of these two terms. Well, just one. Now we look at step 2. This is a binomial, two terms. This is a minus. So this could be a difference of squares or a difference of cubes. We have tools to work with that. And since this is a 4, I think it's supposed to be a difference of squares. So let's try this out. That's x squared squared, because 2 times 2 is 4, right? Let's see, square root of 16 is 4. So that's y squared squared. So here we have a difference of squares. And so we can rewrite this as x squared minus 4y squared times x squared plus 4y squared. Remember, a difference of squares will be those conjugates, as we call them, of these binomials. Now I got to check and see, can I factor this once again? Now, sums of cubes is the only binomial we can do, but these are not cubes, these are squares. So we can't factor this one on the right hand side, but on the left hand side we have a minus. So maybe a difference of squares or difference of cubes is one we can do. And I'm kind of feeling that we have a difference of squares in here. If you kind of see this, this would be x squared minus 2y, because 2 times 2 is 4 and y times y is y squared. So here we do have a difference of squares. So for my answer to this, we'll have x minus 2y times x plus 2y. And I can bring down this x squared plus 4y squared. And that right there is my final answer. So when you're trying to factor a general polynomial out there, go through those steps. First and foremost, look for the GCF. See if there's anything you can pull out. And then go through your steps, see if it's a binomial, we can use those tools. Or if it's a trinomial, we can use those tools. Or, if it's 4 or more terms, you can factor by grouping. Okay. Also, make sure you factor completely, go all the way if possible. And then it's always good to check your work, especially on an exam. If you want to get that A in there, check it and making sure that what is extracted from this is what you started off with at the beginning. Okay, hope all is going well with the factoring.